The LCM is 10, right? 2 times 5, 10. So we put 10 here in the denominator. And then in the numerator, multiply 5.
Today you're welcome to Some Academy. Today we will be looking at Pythagoras theorem, and trigonometry. So in Pythagoras theorem, we deal with a right angle triangle. When we are doing Pythagoras theorem, we have to draw a right angle triangle. A right angle triangle is a triangle that has angle 90 on one side, angle 90 on one side. So we have to draw a right angle triangle, and then we label the other sides. Maybe I can call here A, call here B, and probably here C. Now according to Pythagoras, the guy called Pythagoras, he gave a formula to find this longest side, the one that is facing this angle 90. Remember, this is 90 degree. Okay, these two perpendicular, line A and line B, they form 90 degree. They form 90 degree. So according to this guy, he said if we're looking for this longest side that is facing this angle 90, and we know this A and we know B, if we're looking for C, we simply say C square, the square of C, side C, the square of this line is equal to the square of A, line A, the square of line A, plus the square of line B, plus the square of line B. So he's saying that if you want to find this hypotenuse, this longest side, which is called hypotenuse, if you want to find it, and this hypotenuse is facing the angle 90, is facing angle 90 whenever you have a right angle triangle. If you're looking for this hypotenuse, this side C, we will say it is this side A square plus side B square. So which means if we have, let's say for question 1, if we have this as our right angle triangle, and this is our 90 degree, and here is 5 centimeter, and here is 12 centimeter, and here we call it X or Y. Find X. We call it X. So we can ask you to find X, this longest side. So using Pythagoras theory, using what we call Pythagoras, let's write it Pythagoras, Pythagoras. Using what we call the Pythagoras theorem. This is what we call the Pythagoras theorem. He's saying that whenever you have this type of right angle triangle and the two sides are given and there is angle 90, once we say right angle triangle, you already know there is angle 90. Okay, once we have a right angle triangle, these two sides are given, you're looking for the longest side, which is the hypotenuse. We should simply use this theorem, this formula, which says x squared is equal to the square of the longest side is equal to the square of both sides, the addition of the square of the other two sides, which means 5 square plus 12 square. So this is Pythagoras theory. This is the application of Pythagoras theory. It means 5 square plus 12 square. 5 square plus 12 square. So why? Because it says this longest side, which is the hypotenuse, the square of it is equal to the sum of the square of the other two sides, the adjacent and the opposite, in case there's an angle here. Okay, we're going to come to that when we come to Sokatua, the second part of this lesson. So, where we evaluate now. Once we reach this stage, the next is to begin to evaluate. S square is equal to 5 square is 25. 5 square is 25, and 12 square is 144. So we evaluate it, and then the next thing we add them together. We add it together. After we evaluate, we square each number, and then the next thing is to add them together. So the next one we say S square The next one is S square. The next one is X square equal to 169. 169. Okay, that's not your answer. You're not looking for X square, we're looking for X. Remember that. Okay, we're looking for X. So the next thing to do is to find the square root of both sides so that we can eliminate this square. Right? We've said that severally. The next thing to do is to find the square root of both sides in order for us to eliminate this square. So let's find the square root of both sides. So we write S square S square. Okay. We write S square is equal to 169. But we take square root of both sides. So take square root of this place and take the square root of the left side and the right side. So I take square root here and take square root here. Okay, in this case, the square root we cancel the square. The square root we cancel the square. So this square root we cancel this square. So we have only x left. So we say x equals to what's the square root of 169? I think we get 13. Right? So 13. So our x is 30 centimeter. Our x is 30 centimeter. So it means this place is equal to 13 centimeter. Okay, so this is a simple application of the Pythagoras theory. Is that okay? Not all the time the diagrams looks like this. It's not all the time the diagrams looks like this. The diagram can be written like this. The diagram can be written like this. As, for example, we have this. Okay, the diagram can look like this. We have 14 on the longest side. How do you know the longest side? Is the side that is facing the angle 90. So we have 14 here, we have 12 here, and we have y here. So what if they want you to find the other side that is not the longest side? For example, we have this diagram. Let's take a look at this one. We have this diagram. We have this. Okay, here is angle 90. Here is 14 centimeter. And here is 12. Yes, right? It was 12, right? Here is 12. Yeah, 12 centimeter. And here is y centimeter. Okay, here is 14 centimeter, here is 12 centimeter, and here is y centimeter. Now they want us to find y. So remember, we can label here as ABC as usual, as we did before. Remember when we get this formula, we say ABC, right? So where we say C squared equals to A squared plus B squared. We label the longest side as C. Okay, we label this other side as A and B. So we can apply the same thing here by saying, remembering that A square or C square, which is the longest side, is equal to A square plus B square. A square plus B square. Okay, so we say c square, which is the longest side, is equal to a square plus b square. So if that is true, here is c. If that is true, then we call here c, which is the longest side. You can call here a, and you can call here b. You can call here b. So if you apply that same logic here, so you have 14 square. You have 14 square is equal to a is what? Y. So y square plus 12 square plus 12 square. So in this case, we're going to make y square the subject. So which means if we are not looking for the hypotenuse, we're going to have minus. So what we will have, y square, let's say y square is on the left now, as in we are not moving it. Let's assume it's still on this side. But we are moving the 12 to go and meet the 14. So 14 is still assumed to be on its own side. So we say 14 square minus 12 square. Because the 12 will come to meet it. Minus 12 square, wherever it is. So it becomes minus 12 square. So what we are saying, in other words, is that we can rewrite this one, in case I don't want you to get confused, so we can rewrite this one like this. We assume the 40 square is here, we bring the 40 square, we leave it because it's on the left. So we write the 40 square, okay? But we bring the 12, this 12 plus 12 square, we bring it to the left. It becomes minus 12 square, okay? Minus 12 square is equal to this y square on the right. Is equal to the y square. If you look at it, I only presume that this y square is on this side and these ones are on this side. See the same thing if you look at it. Okay? If you look at it, see the same thing. Okay, but for the purpose of clarity, that's why I quickly have to show you what it is. So 14 square is what? What is 14 square? What is 14 square? And what is 12 square? 12 square is 144. 40 square is 196 for 40 square. So 196 minus 144. 196 minus 144 is equal to our y square. Okay?
50.
So we say y square is equal to what? Yeah, 6 minus 4, 2. And then 9 minus 4, 5. 1 minus 1, 0, so 52. Equals to y square. So the next thing we find the square root of both sides. The next thing we find the square root of both sides so that we can find y. Remember, we're looking for y, not y square. Remember, we're looking for this y. We're looking for this y, this side. This side is called side y. So we take the square root of both sides. So taking the square root of both sides means I take square root of here. I also take the square root of here. So this square root cancels this square. So I have y left. I can write y first for convenience. Y square equals to, what's the square root of 52? 7 point what? 7.21 centimeter. So that's the value of y. That's the value of y, 7.21 centimeter. Okay, so the point is that questions like this can come to you. Questions like this can come to you. Okay, this is how we use Pythagoras theory. We don't have to go through all the things they're writing. We've written them, we've drawn, we've shown you the formula. We've shown you this formula that is a square plus b square equal to c square, or c square equal to a square plus b square. Okay, this is the formula for Pythagoras theory. Okay, the longest side is the one we call the c in this regard, and it's facing angle 90. Is the one that's facing angle 90, and we can designate this place as a and designate here as b. So a square plus b square equal to c squares. That's the formula for Pythagoras theory. If you're not looking for c, you take the square root of c square, it will remain only c, and take the square root of a square plus b square, which will give you this, which will give you this, which will give you this. So c is equal to the root of a square plus b square. Okay, so That's it, we solve example, but let's take a look at a problem that involves more detailed application. Let's take a look at a problem that requires a detailed application of the Pythagoras theory, Here you see that they want us to find x. Is it in the following diagram, AB equals to 12 centimeters, and AC is a straight line. AC, we look for AC is a straight line with AD equal to 9 centimeters here. AD here is 9 centimeters, and AC equal to 22 centimeters. So if we know AC and we know AD, we can find DC, right? You know the whole length and you know part of the length, you can find the remaining part of the length. So we can say AD or DC, this DC is simply the longest AC minus AD. Just say 22 minus 9, you get this DC. You get DC. So once you get DC, and then you use this one to first of all solve for this one. You find this BD. Once you find BD and you know DC, you can find this longest side. Okay? So there are two things to find first. You have to find this place, which is 12 square minus 9 square, because this is the hypotenuse. So you say 12 square minus 9 square, 12 square minus 9 square, 12 square minus 9 square, and the square root of that will give you the answer of BD. Once you get BD, you just say 22 minus 9, you get the answer of DC, and then you can find this x. Now let's solve it. Beyond the explanation, let's solve it. Okay, question number 3. Question number 3. Question number 3. We draw the diagram. So if we have this, we have this 90 degree here, and then also here. Okay, not so bad. Let's say we have the whole length here to be 22. To be 22 centimeters. And we have here to be 9 centimeters. And we say here is A, here is C, here is B, here is D, and here is angle 90, and here is also angle 90, and here is 12 centimeters. So the first thing for us to find, this is a right angle, so this is the hypotenuse, this is the longest side. The first thing for us to find is this one. So we know this is the longest side. It's usually AD square plus BD square that will give rise to AB square. So here square plus here square. So since we know that, we will just say to find here, we don't know here, we will say AB square. See, it's actually like this, AD square plus BD square equal to AB square, equal to the longest side. Okay, this side plus this side equals to this side. Just like you're going to this person's house, you move from here to here, short route, and then from here to here you reach the person's house. But although it's the longest route, single route, but it's the shortest. Instead of following here to here, before you go like this, before you reach this house, just follow here to here, you reach this person's house faster than the total of this journey and this journey. So here is faster, that's the hypotenuse side. So we say equal to AB square. Now, we already know in this question, we know the AB. So we're looking for what? BD. So we make BD the subject. We make BD the subject of the formula. In making BD the subject, you simply say BD square is equal to AB, this AB, the longest side, AB minus AB square, the longest side square. You know, you write AB, you bring AD to this side, you bring AD. When you bring AD, it becomes minus. So it becomes AD square, say minus AD square. Okay, so that's how. So if you're looking for the longest side, we will add this plus this one square plus this one square. But we already have the longest side. We have the longest side. We're looking for one of the short sides. So you say this longest side square minus the other short side square. So you get this one square. So that's how we got this formula. AB square minus AD square equal to BD square, equal to this one. Okay, because we're not looking for the longest side, we're looking for one of the short side. So in doing that, we quickly say our BD square is equal to AB square is 12. AB is 12. So I simply write 12 square minus AD is 9. AD is 9, so minus 9 square. So the next step, you just simply say BD square. Remember they asked us to find this place, X. They call it X. They asked us to find here. Okay, so we are working, we start from here till we get here. Okay, now we're working towards that. So we have BD square is equal to 12 square is 144. 144 minus 81. So 9 square is 81. 144 minus 81. So the next step, we subtract this, right? 4 minus 1 is 3. 14 minus 8 is 6. 63. Okay, so we have BD square equal to 63. So we take the square root of both sides. We take the square root of both sides. We take the square root so that we can remove the square here. And we also take the square root of here. So square root of this, we have only BD. If you take square root of BD square, you get only BD. Is equal to, what's square root of 63? 7 point what? Almost 8. You know 64 would have been 8. If your square root of 64, it would have been 8. 7.9 what?
7.937.
So we say 7.94 centimeter. Okay, so that's our BD, 7.9, approximately almost 8. Okay, so here we have 7.9. Our BD, we have 7.94. Now we don't have to solve here. This one is simply by saying 22 minus 9, right? Here is 9, here is 22. So 22 minus 9 is what? 13. So here is simply 13. So you're looking for the hypotenuse because it's facing there, another right angle triangle side. You're looking for the hypotenuse side because it's facing this the right angle triangle. The angle 90. It's facing the angle 90. So you will say, you can put centimeter, okay? 30 centimeter, 7.94 centimeter. So here we're looking for the longest side. So since we're looking for the longest side, we're going to say this one square, BD square plus DC square. BD square plus, so to find BC, we can write it here. BC square, to find BC, the longest side square, is equal to the other two sides square, the sum of the other two sides square. So to find BC, which is X, you say BD square is equal to BD square plus BD square plus DC square plus DC square. plus DC square. Is that okay? Okay, so now BC square is x. So I can simply write x square. X square is equal to, our BD is, BD square is 7.94. You square it. When you square it, you get back your 63. 7.94 square plus 13 square. This one, DC plus DC square plus DC square. So which is 13. So we square 13, number 13, we square it. So if you square this, remember just now, it was when we found the square root of 63 that we got 7.94. So this will simply, you refresh your mind, you don't have to look for calculator quickly. You knew that you got this number from the square root of 63. So when you square it, you also get back 63. So we say this is 63 plus 169. 13 square is 169, right? So plus 169. Quickly add them together. What do you get? If you add them together, you get what? 2. Carry 1 here. You get 13. Carry 1. You bring the 1 here, become 2. 232. So we get 232. S square. Sorry, here is square. S square equals to 232. Now to find x, remember they asked us to find x. The question says find x. Find x, not find s square. There is no s square in the form in the diagram. It was only x that was on the diagram. So find x. So since they asked us to find x, we have to find x by looking for the square root of both sides. Finding the square root of both sides. So but in doing that, you just introduce your square root here, square root of s square, you get x. And square root of 232, what's the square root? 15.23. You get 15.23. Okay, so that's your answer for s centimeter. 23 or 24. The next number was supposed to be what? Okay, so you get 15.2, 15.23, 15.24, so as the case may be. Okay, so this is what you get for x. This is how we find Pythagoras theorem. This is how we apply it. Okay, when you're given any problem. This is how you apply 15.23. See, in the end we got 15.23. So we must learn how to apply it. Okay, and in doing that, we've mastered the use of Pythagoras theorem. Once you're able to find the longest side or any side, if you're able to find the C, if you are given A side and B side, by saying A square plus B square equal to C square. But if you ask to find A, they didn't give you A, they gave you C and B, you say C square minus B square.